Everyone. So our today's lead code question is 401, that is binary watch. So in this question we are given a binary watch that has four LEDs on the top to represent hours between 0 to 11. You can see here we have four LEDs representing 1, 2, 4 and 8, and 6 LEDs on the bottom. 6 LEDs on the bottom to represent the minutes between 0 to 59. 0 to 59, and each LED represent a 0 or 1. Means if it is on, then it represent 0, else it represent 1 with the least significant bit on the right. So if you can see in this watch, so what is the time it is showing? The hour is 4 and the minute is 1 plus 2 plus 16 plus 32, that is 51. So this watch is showing the time as 4:51, right? Next, so here we are given an integer turned on, which represents the number of LEDs that are currently on, and we have to ignore the PM, AM or PM LED, right? We won't be considering that. And we have to return all the possible times the watch could represent with these number of turned on LEDs, right? And we can return the answer in any order. So suppose, and some rules are given. 0100 is not valid, it should be 100, because for hours must contain a leading 0, must not contain a leading 0, like hours must not contain a leading 0, and minute must consist of two digits and may contain a leading 0, right? These are the two conditions that we have to follow while forming the answer. So see, 10 2 is not valid because here minutes is only one, what we called one digit. It should be like 1002, 1002. So hours should not have any leading 0 and minutes can have a leading 0. So if you'll see the example 1, here we are given turned on is equal to 1, that is the number of bits that we can turn on is 1. So hours were 1 2 4 8, minutes were 1 2 4 8 16 32. So we each time we can turn on one bit. So if we'll turn on this bit, then our time is 1. If we turn on this, our time will be 2. If we turn on this, our time will be 4. If we turn on this, our time will be 8. Similarly, if we turn on these bits one by one, if we turn this, then our time is 0 1 minute, then 2 minutes. So the total answer that we are getting is 10. These 10 possibilities can be there when the turned on is equal to 1. Next is turned on is equal to 9, right? So we have to close one bit, right? So suppose, is it possible to on these 4 bits at a time? Our R should be less than 12, right? But if we turn on all these 4 bits, then 8 4 plus 8 4 12, 12 to 14 and 1 15, we are getting 15. So we can't turn on all these 4 bits. So what we can do is either we can turn 8 to 1 or 4 to 1, right? And so if we can't turn on these 4 bits, we have closed one bit here, right? Then here how many are left? 6. So we have to turn on all these 6 bits, but their sum is greater than 59. So it is violating our minute case. So it is not possible to make any valid time using 9 bits. That's why our answer is empty here. And if you see the constraints, turn on can be up to 10, right? So let's see the approach. So we will be discussing the brute force approach, which is sorry, yeah, we will be discussing the brute force approach. So basically the our hours can be from 0 to 11 and minute can be from 0 to 59. So here 12 possibilities, here 60 possibilities, right? So total possibilities 12 into 60, that is 720 possibilities. Uh, So can we check all these possibilities? Yes, 720 is a very small number. So we can try out all these possibilities. So what we do is we take every possibility for RH and minute M, right? And then what we do is we count the bits in the current RH and in the minutes M, and if the sum of the total bits, that is the bits of hours and the bits of minutes, is equal to the turned on bits, that means this time can be made from the number of bits given to us, means that is a possible answer. So we'll be storing that answer hours and then minutes, right? I'll tell you again. Suppose let's take h is equal to 4 and m is equal to 56. So what we do is we'll count the number of bits in this. So it is 0100. So the number of bits is 1 and this is 56. So 32 plus 16 plus 8, right? So 1 1 1, then all zeros. So here the number of bits is 3. So total bits is 4. And suppose a turned on is also 4. So this time can be made with 4 bits, means if turned on is equal to 4, then that can be a possible answer, right? So what we do is we will be storing 456 as one of the answer, right? So the next thing is how to count the number of bits in this hours and time. So for this we can use either our own functions that we have made, or we can also use inbuilt function. So this inbuilt function underscore underscore built-in underscore pop count of any n, it will return us the number of set bits in this n, right? Or we can use our own function, that is int n. What we are doing is while n is greater than 0, we check the first bit n and 1. What n and 1 will give us? If n, the first bit of n is 1, so it will give 1. If first bit of n and 1 n is 0, then it will give us 0. So if it is 1, then we'll increase our count by 1, else we are adding 0. So it will give us the total counts of bits, and then we are right shifting our n. Suppose we have 1011. So 1 and 1 initially will end these two. So 1 and 1 will give us 1. So our count has become 1. Then we have right shifted it. So it become 101 and 1. Again 1. Count will increase to 2. Again right shifted 10 and 1. It will give us 0. So count 2 plus 0 is 2 only. Then 1 and 1 1. So again our count has become 3. Right. So this way we get the count of the bits, or you can either use this inbuilt function. So let's see the code of this. So we have made a vector of string to store the answer, and then we have iterated from h is equal to 0 to 11 and minutes from 0 to 59 to check all the possibilities. And then we are counting the bits in the current hour and the current minute. So that will be a total bits, and if it's total bits is equal to the number of bits that we are given, that means this is a possible answer, then we will be converting this time to the string to store the answer. So we will be using function toString. First we convert r, then this semicolon, sorry, this colon. Then we are given that minutes should be 2-digit number. So if minute is less than 10, then we add a 0 here and then convert the minute to a string. Else if minute is greater than or equal to 10, then we directly can store 10 11, right? So that's what we are doing here, and then we are pushing the time into the answers vector, and at the end we return the vector, right? So what other approach can we follow? So here we have 4 bits for hours and 6 bits for minutes. So total is 10 bits. We have total 10 bits, 4 for hours, 6 for minutes. So can't we like check every possibility with turned on these bits, right? Suppose we are given 4 turned on equal to 4. So we have 10 bits. So set any we can set any 4 bits and then check whether this is a valid time or not. If it is a valid time, then we store that, right? And what is the valid time? If r is less than 12 and minutes is less than 16, then that time is a valid time. So here we have 10 bits. So what are the total possibilities? This bit can be either 0 or 1, right? So for every bit we have two possibilities, and such we have total 10 bits. So total possibilities are 2 ki power 10 total possibilities, right? Which is 1024. So this will also be feasible. So if you want, you can try out this approach also. I hope I am able to explain you both the approaches properly. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.